So Pythagoras theorem statement. The statement of the Pythagoras theorem is in a right triangle. Most of the students will forget to state the right triangle. Simply they'll say that it is right triangle only. Hypotenuse is there means right triangle only. Right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So to improve, it means little bit to improved version, if you want to say, the square of the length of hypotenuse better you use. It's my point of view. I'm not saying it is wrong here. Square of the length of the hypotenuse is equal to the sum of the squares of the lengths of other two sides. So the statement is this one. And to prove this statement, we need to use that. Let us take the triangle of PQR, in which angle Q is 90 degrees is taken. Means angle PQR is 90 degrees. Therefore, RPR becomes a hypotenuse, and PQ and QR are other two sides. So we need to prove that PR square is equals to PQ square plus QR square. So let us drop the one perpendicular from the Q onto PR, that is QS. Perpendicular draw kar liya hai. So after drawing the perpendicular, here you can compare these smaller triangles with big triangle. These two smaller triangles with a big triangle, that is nothing but QSQR triangle, PQR triangle, or QPR triangle. So these triangles se compare karna. Okay. So whatever the triangles we are taking, PQR triangle and the triangle PSQ is triangle. PSQ, the smaller part is taken into consideration. So in these two triangles, if you see that angle QPR is in PQR triangle. What is angle QPR? Angle P, common angle. Angle SPQ is also there here. This angle. Is it visible to you, the arrow mark?
Yes, sir.
So which triangles we are taking into consider? This triangle and the bigger one, complete full triangle. In these two triangles we are comparing. Here this angle is common and this angle 90, here it is angle 90. So by AA similarity criterion, you can say that these two triangles are similar, but the naming is very clearly you need to concentrate. What are the names should be given here? PQR, whenever you are saying P, angle P, Q 90 degrees. So second triangle also PSQ is better, you say here. So triangle PQR is similar to triangle PSQ by AA similarity criteria. Okay. AA similarity criteria, these two triangles are similar, PQR. So now whenever these two triangles are similar, corresponding sides are in proportion. So here you need to take the corresponding sides in which 2 times PQ we are going to get. Here PQ by PS is equals to PR by P. So from this you can say that cross multiplying PQ square is equals to PR into PS. This you consider equation number 1. In the same way, you need to take the other triangle, that is RSQ triangle, and RSQ whenever you take, name the triangle as a PQR whenever the name is given, PQR is given triangle name, and QRS better you give the name because R is common here and S is equal to Q. So angle R is nothing but in both the triangles angle R is there, that is this angle, that is QRP and QRS, and angle 90 degrees is there. Therefore, similarly by AA criterion, the two triangles PQR is similar to QSR. So now the corresponding sides are in proportion. From that QR by SR equal to PR by QR, QR square equal to PR into SR. This is equation number 2. And equation 1 and 2 you add PQ square plus QR square is equals to PR into PS plus PR into SR. So take the PR common. Take the PR common. So what do you get? PS plus SR. So what is PS plus SR here? PS plus SR, completely PR. So PR into PR, that is nothing but PR square. So this is the Pythagoras theorem. Did you understand here? So you can able to prove this Pythagoras theorem. If you are practicing the Pythagoras theorem, I suggest you to practice the Pythagoras theorem with a different names: PQR, ABC, KVP, like that, IND, India. Different names you take. One time in one way you practice. So that main idea, main concept you are going to understand. Same name if you are practicing, automatically that just like you are going to mug up it. As it is there, that symbols will be remembered in your mind. You can remember it in the mind, and you are as it is present. Change the name every time whenever you prove it. So I request you to prove this theorem in your notebook, everyone, with your name. Suppose my name is Ragi Uday Kumar. If I want to prove it, RUK, triangle name, I will take RUK. Like that you take with your name. If it is possible, means सब लोगों को 3 letter नहीं आ सकता है, but whatever it may be, every student has to take the different name, and you try that proof. So don't mug up that. Okay, so you do like that, so that you will be able to learn it. Next thing, converse of the Pythagoras theorem. In a triangle, if the square of the one side is equal to the sum of the squares of the other two sides, then the side angle opposite to the first side is rectangle. One side square is equal to the sum of the squares of the other two sides. One side square is, if it is equals to the sum of the squares of the two sides. So here it is triangle ABC. B is not 90 degrees here. It is given that AC square equal to AB square plus BC square. So B, we need to prove 90 degrees. Angle B 90 degrees. So let us take the one triangle ABC in which angle Q is 90 degrees, and PQ equal to AB and BC equal to QR. AB, PQ equal to AB, QR equal to BC. Let us take the one triangle, but that triangle में angle P 90 degrees ले. So angle P 90 degrees. So angle P 90 degrees whenever you are taking, PR square equal to PQ square plus QR square आ जाएगा. So PR square equal to AB square plus BC square, because if we have taken AB equal to PQ, we have taken BC equal to QR. So in the place of PQ, AB is replaced. In the place of QR, BC is replaced. We are going to get AB square plus BC square. So what we are going to get here from this? It is given that AB square plus BC square is AC square. It is given. Okay. But from this, what you can say, we are, according to our assumption, AC square is equal to PR square equal to BC square plus AB square. But given AC square equal to AB square plus BC square, from that AC square and PR square are equal. From that AC equal to PR, we are going to get. We have taken. So these two triangles, corresponding sides equal आ गया. We have taken only two sides are equal. With one angle is equal. One angle is equal to 90 degrees. So you can say that the two triangles are congruent, not similar here. So they are by SSS congruency, these two triangles are congruent. So when these two triangles are congruent, their corresponding angles are equal. Corresponding angles are equal. Angle B is equals to angle Q. So angle Q we have taken 90 degrees. That's why angle B is also 90 degrees. So this is a theorem here. Converse of the right angle. Sorry, converse of the Pythagoras theorem. And whenever you see here, and the important point I want to say that it is stated as, the Pythagoras theorem is stated as in another way also, which is known as UDAY'S theorem, which is given to you in your textbook, and most of the students will neglect it. See, this is a theorem given to you. He is the Pythagoras, and 516. In your textbook itself can, but most of the students, I assure that, will be neglected that point. Yeah, if a perpendicular is drawn from a vertex of the right angle triangle to the hypotenuse, then the triangle on the both sides of the perpendicular are similar to the whole triangle to the each other. One theorem. Already this theorem we have discussed. यही theorem को use करके हम एक perpendicular draw करने के बाद right angle triangle में ये छोटा two triangles है ना, वो बड़ा triangle को similar होता है. That is the only thing here it is given to you in this statement. This is not the Pythagoras theorem statement. This is one theorem, and we will use this theorem to prove the Pythagoras theorem. Okay, so this already we have proved it in the Pythagoras theorem only by dropping the perpendicular from the vertex where the 90 degrees is formed. Okay, so Pythagoras theorem statement is originally this one 6.8 statement. Here in this question, here it is mentioned to you ABC triangle. That's what I said. You name the triangles in different ways. Here angle B is 90 degrees. And coming to the last here, yeah, here it is given to you. The theorem was earlier given by an ancient Indian mathematician, Bodhaya, about 800 BC, in the following form. Actually, Pythagoras belongs to 569 to 479 BCE. Okay. Earlier, 800 BC. I think you know that the years before Christ will be decreasing. So 800 BC is nothing but very before the Pythagoras. Pythagoras is 569 to 479. Everything you need to understand whatever it is given in your textbook. That's why I'm explaining to you this. Okay. So the statement is the diagonal of a rectangle produces by itself the same area as produced by its both sides. The CAS statement is most of the students will get confused. Diagonal of a rectangle produces by itself the same area. So what is the area of a rectangle? Diagonal of a diagonal. Yes. So here produces the same area, means diagonal whatever you are taking in a rectangle, the diagonal of a rectangle produces by itself the same area as produced by its both sides. So area is nothing but square of the diagonal ka square le lo. Area of the means it produces, means a square described on a diagonal. Previously one problem we have seen that square equilateral triangle described on a diagonal का ऊपर एक described हो गया. In the same way, you consider that this theorem statement what it says you, I will explain to you through the figure. So for this reason, sometimes it is also referred to as a Bodhaya theorem. ये statement बहुत ज़्यादा लोग neglect करते हैं. So this is Bodhaya theorem altogether. What Bodhaya theorem statement is what here exactly? A rectangle produces by itself the same area as by its both sides. So that is nothing but here there will be a little confusion to say that one. So you take the one rectangle. Let us take the one rectangle like this. A, B, C, D. So A, B, D is the one. BD is the one diagonal. What is the area of the square described on this? इसके ऊपर square हो गया है, उसका area क्या है? That is nothing but like this square is developed here. What is the area of this one? BD square है ना? Produces the area. It produces by itself the same area. Diagonal produces and the area of the square on this. इसके ऊपर square है. So what is the area of that one? AB square. And इसके ऊपर एक square area. Square is given. So what do you get here? Plus AD square. BD square is equals to. So indirectly it is a Pythagoras theorem only, na? BD square is equals to whenever it is stated like this. Did you understand the statement? The diagonal of a rectangle produces by itself the same area as produced by its both sides. Producing means ये produce कर रहे area means square should be taken on this. So this you avoid when you are avoiding this one. Then it is Pythagoras theorem or not? Yes, it is Pythagoras theorem. So it is actually referred to as, normally it is named as a Bodhaya theorem. Okay? Did you understand? समझ में आया?
Yes, sir.
Yes.